What's up, guys? How's life going on there? It's the moment of truth to implement what we have learned in our firmware programming, our crash course for our amplifier hobby using the popular Intel 8051 core, the STC90C516RD Plus as our controller, and the basic program with the Bascom 851 to write our code. And if you are watching the series from episode 1 to 9, you will find it out that even as a beginner with no experience in microcontroller programming, as long as you know a little bit of hardware, you will find it out that it's easy with confidence to implement in our amplifier hobby, upgrading our technical know-how, not just simply with our amplifier, but with the art of programming as well as making a human-machine interface. I'm really glad you stick around until episode 10. Thank you for that. Let's take a look at it from the front panel. By its casing design idea, we can see the LCD and the power on off switch, and I can now execute to power on or power off my amplifier, of course with style. It looks like my project is talking to me, giving me information what it's doing in the background, like in the power on or power off process, of course with the mute and standby control running in the background. Let's see that in terms of TTL level, that is called transistor level, as we really don't have yet the TDA8920 Class D amplifier. It's still here actually, still planning to build it, populate the component. In here, the standby logic control goes logic 0 when you power on, and it goes logic 1 when you power off from its initial state of logic 1. It's basically the equivalent by switching a toggle switch like this one, on and off, flip it up to power up, and flip it down to power off. The mute will be delayed by a few seconds, meaning the speaker is not connected when you just power on the DR100 concept amplifier. Normally it is about 6 seconds after turning the amplifier that will give enough time to stabilize the amplifier and kill noises. And then it really goes logic 0 in the power on, and it goes logic 1 first before turning off the amplifier. Probably with the TTL level, we can't see the benefits, or we cannot imagine what is exactly going on with the mute and the standby mode. But by adding a relay on the standby and mute control pin, it can be easily seen how is the sequence like this one. So this relay here is the standby mode, or in the class AB power amplifier, you're actually controlling the AC power supplied to the power supply. And the other one in here is the speaker relay, which is there is a delay of about 6 seconds in order once again to kill the noise in the power on. And in going into the standby mode, the speaker will disconnect first, and then followed by disconnecting the AC 220 volts that is supplied into the power supply of the amplifier. In this sequence, you will prevent of noises that's possible happening in a class AB amplifier. Well, what do you think, guys? Well, that's it for now. Yeah, really, for the time being, while we are developing all our hardware and its dedicated program, and should you decided to add it into your existing power amplifier right now, and I also expand the idea to make use of a speaker protector using the NEC chipset, the UP1237 or C1237HA, which is a dedicated chipset for the speaker protection. we will not be discussing here. It's gonna be a separate video, but you probably can explore the idea and check the speaker protector datasheet that is set to give you more information. You can find it on the download link, which I shared it in the description below. Guys, this will going to end our man-machine interface programming of our amplifier project. I really hope that the 10 episodes will give you at least an idea on how you able to implement your own man-machine interface on your own amplifier project. Something original, something that you like to display on the front panel of your amplifier, something that you can change it from time to time by simply a trick on the programming code at no cost. Oh, by the way guys, do you know what is this? It's actually blinking right now on the top of my speaker. Can you guess what is it? Come on guys, just for fun, let me know on the comment below what is this on the top of my speaker. The next episode will be more interesting on both the hardware and programming, because we will going to make use of the I2C protocol, that so-called inter-IC communication protocol developed by Philips. Well guys, let me know what do you think our next episode on the I2C. Let me know on the comment below or on my personal email. And if you like my content, kindly consider subscribe by actually clicking the subscribe button below. You are supporting my channel to grow and will keep me here at YouTube. You might like to share my videos as well to those guys who might need this kind of content. Thank you for sharing. Guys, this is the end of episode 10. Stay tuned for the next episode and see you in the next video.